Hi, my name is Bamani Gerard, and you're welcome to Bamani Farm Lectures. Today's lecture is going to be about dilutions, and please, if you like this video, please subscribe to my channel and share it with others who may also find it useful. Let us get started. You're first with a prescription where you're required to prepare certain meals of a 0.25% from the stock solution. The question is similarly the same to what we covered in our first lecture. So we want to see how we can obtain or calculate for the volume of stock solution that will be required in order to prepare this prescription. The thing we need to do is to know what we are required, and secondly, to identify the variables. Which one is our V1? Which one is our V2? Which one is our concentration 1? And which one is our concentration 2? Since they want you to prepare 0.25%, it means that this will be our final concentration, and the certain meals will become our final volume. Therefore, we shall say that C2 is equal to 0.25%, and our final volume V2 is given as 30 mils. But remember, we are preparing this solution from a stock solution with a concentration of 1 to 50. Therefore, this becomes our initial concentration. So we shall have our C2, initial volume, initial concentration as being equal to 1 to 50. But since in our prescription the concentration is in percentage strength, we shall also be required to convert the ratio strength into percentage by simply multiplying by 100. And we shall have our initial concentration as being 2%. Now, we also need to know the final volume, and that's what we are looking for. Therefore, from our formula, we know that product of the initial concentration and initial volume is equal to product of the final concentration and final volume. Therefore, when we try to fill in our equation, we shall have C1 as 2 times our initial volume, which will be equal to 0.25 being multiplied by 30. When we make V1 the subject of the formula, we shall have V1 being equal to 0.25 times 30 over 2. And this will give us 3.75 mils of the stock solution. Let us look at the next question. Let us look at our next question. How much drug should be used in preparing 50 ml of a solution such that 5 ml diluted 500 ml will yield a 1 to 1000 solution? So this means that they have given us 50 ml of the stock solution. And from this 50 ml of the stock solution, they picked, we had 50 ml. We had 50 ml of the stock solution, and from this 50 ml of the stock solution, we picked only 5 ml and we placed it in another measuring cylinder, so our volume was 5 ml. And then from there, we diluted these 5 ml up to 500 ml mark. So we diluted this solution up to 500 ml mark. And after diluting it to this volume, the concentration of the final solution was 1 to 1000. That means that also our volume V2 is 500 ml. So they want us to obtain how much drug was in 50 ml of the stock solution. But remember, we picked only 5 ml from the 50 ml and we diluted it to 500 ml, which gave us a concentration of 1 to 1000. So what do we know? We know the concentration of the diluted solution and its volume. That means that since we know the volume of the diluted solution and its concentration, we can use that relationship between volume and concentration in order to obtain how much of the drug is in 500 ml of the diluted solution. So we shall say amount of drug in 500 ml of the diluted solution will be equal to, you know that 1 to 1000 means 1 gram in 1000 ml of a solution. So we have 1 out of 1000 times our volume, which is 500 ml. Remember, this one is in mils, and as well this one is in mils, so the mil and the mil will cancel, and we shall have our answer as 0.5 grams. So we have 0.5 grams of the drug in 500 ml of the solution. But just like we looked at dilution in our first lecture, we know that the amount of drug in 500 ml of diluted solution is the same amount of drug in 5 ml. So, since 0.5 grams of the drug is the same amount of drug in 5 ml, that means that we can be able to obtain how much drug is in 50 ml of the stock solution. How do we do that? We are going to set up equivalent fractions, where we are going to say that let X represent amount of drug in 50 ml of stock solution. So we know that 0.5 grams of the drug is in 5 ml, which will be equal to X, which is the amount of drug in 50 ml of our stock solution. So when we cross multiply, we shall have X being equal to 0.5 times 50 divided by 5. Finally, we shall have X being equal to 5 grams. So we have 5 grams of the drug in 50 ml of our stock solution. If you do not want to use equivalent fractions, you can as well do this from first principle, where we shall say that 5 ml of the solution contains 0.5 grams of the drug. Therefore, 50 ml of the stock solution will contain 0.5 out of 5 times 50, and this will give us 5 grams of the drug in 50 ml of our stock solution. Let us look at the next example. Our next example reads, how many grams of sodium chloride should be used in preparing 500 ml of a stock solution such that 50 ml diluted to 1000 ml will yield a third normal saline for irrigation? So, the first thing you need to identify what you need. They want us to calculate for the amount of sodium chloride that was used in preparing 500 ml of the stock solution. such that that means that we had a stock concentration, of 500 mils of sodium chloride, but we didn't know how much of sodium chloride was in this 500 mils. So from this 500 mils, we picked 50 mils. And this 50 mils that was picked from our stock concentration solution was diluted to 1000 with the solvent, giving us a concentration of the diluted solution as being a third normal saline. So that means we need to begin by calculating for the concentration of normal saline in our diluted solution, whereby we shall say we know that a third normal saline is the same as saying 1 divided by 3 times 0.9%. We know that the concentration of sodium chloride is 0.9%. So if it is a third normal saline, it means a third times the concentration of normal saline, which will give us 0.3% as being our concentration of the diluted solution. So now, after obtaining the concentration of the diluted solution, we are going to obtain the mass or the amount of sodium chloride in 1000 mils of the diluted solution. So we shall say that amount of sodium chloride in 1000 mils of diluted solution will be equal to 0.3 out of 100, because we say that 0.3% simply means 0.3 grams in 100 mils of the solution. That's where we are getting this, and then we shall multiply this by 1000. This is in grams, this one is in mils, and also this one is in mils. The mil and the mil will cancel, and our answer will remain in grams. So we shall have 3 grams of sodium chloride in 1000 mils of the diluted solution. But remember, getting 3 doesn't mean we have gotten the answer, because they need us to obtain amount of the drug in 500 mils of the diluted solution. But remember, we say that the amount of drug in 1000 mils of the diluted solution is the same as that in 50 mils of the solution. So that means that 3 grams is the same amount of sodium chloride in 50 mils of the solution. So we are going to say that 50 mils of the solution contains 3 grams of sodium chloride. How about the 500 mils of the stock solution? Therefore, 500 mils of the stock solution will contain 3 out of 50 times 500 grams of sodium chloride. So this one will give us the 50, reduce this by 1, and we shall have 30 grams of sodium chloride in 500 mils of the solution. Let us look at our next example. Let us look at our next example. How many mils of water should be added to 100 mils of a 1 to 125 volt in volume solution to make a solution such that 25 mils diluted to 100 will yield a 1 in 4,000 dilution? So you want to determine how much water was added to this with this concentration such that the 25 mils diluted to 100 will yield this. So we are going to begin with, first of all, determining how much of the drug is in 100 mils of the diluted solution, and also how much drug is in 100 mils of the stock solution. So, amount of drug in 100 mils of the stock solution will be equal to 1 out of 125 times 100. This is in mils, this is in mils, this is in grams. So when we multiply that, we are going to obtain 0.8 grams. That means that we have 0.8 grams of the drug in the stock solution, and therefore it is this to give us the final volume of that solution. So let us also obtain amount of the drug in 100 mils of the diluted solution, which will be equal to 1 out of 4,000 times 100 mils. So this will give us 0.025 grams of the drug in 100 mils of the diluted solution. So now that we know the amount of drug in 100 mils of the diluted solution, remember we said that since 25 mils was diluted to this, that means that the amount of drug in 100 mils is the same amount of drug in 25 mils of the stock solution. So we are going to say that if 25 mils of the solution contains 0.025, how about in our stock solution? But this time around, remember, what we want should be in mils. So that means that when working out from first principle, what you need is always on your right, and what you have is always on your left. So what we have is the mass of the drug in the diluted solution and mass of the drug in our stock solution. So what we want is the volume of drug, volume of the stock solution. So we shall say that 25 mils of the stock solution contain let us change it because what we want is the volume. So we shall say that 0.025 grams of the stock of the drug is in 25 mils of the stock solution. How about the 0.8 grams of the drug will be in 25 mils over 0.025 times 0.8 grams of the stock solution. Therefore, we will have, when we compute this, we shall have 800 mils of the stock, 800 mils of the stock solution. So this is our volume, total volume of the preparation. So we are going to obtain amount of water that was added to our stock solution. We shall say that volume of water added will be equal to final volume minus now the volume of the stock solution, and therefore this will be 800 mils minus 100, which will give us 700 mils of water. Let us look at the other example. Or alternatively, before we can look at the other example, if you do not want to calculate this from first principle, we can let the final volume be x, where we shall say that 0.025 grams is in 25 mils. Now, the 0.8 grams will give us x. So now our x is going to be equal to 25 times 0.8 being divided by 0.025, which will also give us 800 mils. And we shall have the difference between this and 100, which will also give us 700 mils of water. So let us look at our next example. If 15 mils of a 0.06% ipratropium bromide nasocipre were diluted with 6 mils of normal saline solution, what would be the drug concentration? So, if 0.06% of 15 mils of ipratropium bromide nasocipre were diluted with 6 mils, the resulting, what is the concentration of the resulting solution? Because initially we had 0.06 in 15 mils. So when these 15 mils were diluted with 6 mils of the solvent, now they want us to obtain what was the concentration of the diluted solution. So we are going to begin by obtaining the amount of ipratropium bromide in 15 mils. Therefore, we shall say that amount of ipratropium bromide in 15 mils will be equal to 0.06 divided by 100, because we are now aware that 0.06 means 0.06 grams in 100 mils of the solution. So we shall multiply this with 15 mils. Since this is in mil and this is in mil, we shall get our answer in grams, and that will be 0.009 grams of ipratropium bromide in 15 mils of the solution. So that means now we know the mass of ipratropium bromide in 15 ml of the solution. But remember, this 15 ml of the solution was diluted with more 6 ml to give a concentration they are asking for. So that means the 0.09 grams of ipratropium bromide is the same amount of drug in our final volume. So our final volume will be, now, the 15 ml of our initial solution plus the 6 ml. This will give us 21 ml. So this is our final volume after diluting our ipratropium bromide nasocipre with 6 ml of the solvent. Therefore, we want to know how much concentration will be in this volume. So we shall say concentration of the drug in 21 ml of final volume will be equal to 0.009 grams over, now, the 21 ml times 100. This one will give us 0.043%. So you realize that the concentration reduced when we added more solvent to our original solution. Thank you for watching, and please don't forget to subscribe to my channel to promote it and also to share it with other colleagues who may also find it useful. Thank you. We meet in our next lectures.